This is something you are definitely using every day, or maybe you are not, but for those who don't know, it's a shower hose. It's a metal shower hose, and inside there's a rubber hose, a rubber core, and as usual it breaks and the water starts leaking through the metal shielding because it's not watertight. And you probably wonder what my multimeter is doing next to my shower hose. And it's because I'm going to measure its resistance. And its resistance is about 5 ohms. And I had a crazy idea to make a deadly self-heating suicide shower hose. That's basically a long piece of metal with some resistance, so I wonder what happens when I connect a voltage to it. And yes, your guess was right, that voltage is gonna be a mains voltage. Now it's powered up. It's running. Yeah, it was quite a significant power. And unfortunately my breaker tripped. But let's try it once more. 3, 2, 1, go. And it still trips my breaker, so let's try to put a diode in series to limit the power. Or actually a few of them. And instead of 16 ohm breaker, let's try 25 ohm breaker. Okay, let's give it one more try. Nice! So the insanity is over and let's do the aftermath. This is the shower hose after the experiment, and as you can see it's a little bit blackened. And what I was actually doing was I was connecting a 5 ohm resistor to mains via a 16 ohm breaker. The mains is 230 volts, 50 Hz. And what was the current? The current is I equals U over R, and it is 230 divided by 5, and this is 46 amps. And that's why my breaker was tripping after a few seconds. So later I have added a diode into the circuit to limit the current. And because the diode only passes 1/2 cycle, it limits the average current to half. So now the current was 23 amps. But this was still too much for my breaker and it still kept tripping. Later I have connected this bloody thing to a 25 amp breaker and it was much better. And because of the diode, the current was only 23 amps. Because the diode only passes 1/2 cycle of AC current. And when I connected it to the mains, all the lights in my house were flickering because it was only loading the mains in 1/2 cycle, and so the 1/2 cycle was loaded and the voltage dropped in this half cycle, and the other half cycle wasn't loaded, so the voltage didn't drop. So the mains voltage at the time looked like this. And normally in a fluorescent tube all the half cycles would blend and make 100 Hz ripple, which is not visible to human eye, but because 1/2 cycle was loaded more, it was blended like this, and I could see a 50 Hz flicker. And the 50 Hz flicker, unlike the 100 Hz flicker, is visible to human eye. And the power of my shower heater was P equals U times I, and this is 230 volts times 23 amps, and it is about 5.3 kilowatts. And that's a nice power. and all the breakers and the electricity meter were buzzing. And finally the turns of the spiral welded together and decreased the resistance, so the breaker tripped anyway. And it was a really crazy experiment. Don't try to do this because it's extremely dangerous. And this is my makeshift high current diode. And this is Diode Gone Wild, and see you in my next videos.